Okay, so I'm pretty sure the main question that people are going to be asking is why ivermectin? So, here, I'm going to present to you the why. So, the reason why we're going to go with ivermectin, there was this study published back in 2020, September of 2020, um, about ivermectin being a potential anti-cancer drug. And yeah, so basically, it shows that it has powerful anti-tumor effects, including the inhibition and proliferation, metastasis, and uh, angiogenic activity in a variety of cancer cells. This may be related to regulation of multiple signaling pathways by ivermectin through PK1 kinase. I don't know if I said that word right, but on the other hand, ivermectin promotes programmed cancer cell death, including apoptosis, autophagy, and pyroptosis. Ivermectin induces apoptosis and autophagy and is mutually regulated. Interestingly, ivermectin can also inhibit tuber stem cells and reverse multi-drag resistance and exerts the optimal effect when used in combination with other chemotherapy drugs. So, not only can it be used by itself, but it can also be used in combination with chemotherapy drugs, which we'll talk about in a second. So, head down here. This basically tells you what ivermectin is. It's a macrolide antiparasitic drug with 60-membered ring that is widely used for the treatment of many parasitic diseases such as river blindness, elephantitis, scabies, and Satoshi Omura and William Campbell won the 2015 Nobel Prize in Physiology for Medicine for the discovery of the excellent efficacy of ivermectin against parasitic diseases. Recently is reported to inhibit peripheral proliferation of several tumor cells by regulating multiple signal pathways, which suggests that ivermectin can be an anti-cancer drug with great potential. And in this, they review it for its possibility of being an anti-cancer drug. So this is what comprises ivermectin. If you want to read through this on your own, I'll drop a link to this article in the description of the video. But right here, you can see this is the chemical compound of ivermectin. These are the sister siblings. And let's see. Yep. So not only does it have antiviral effects, also has antiparasitic effects, but also has inhibitory effect on the COVID virus, as well as potential for clinical application in asthma, neurological diseases, and recently it has a strong anti-cancer effect. So this is what it does, because it treats every cancer differently. However, it still has the same principle behind it for each cancer. Uh, there's one for breast cancer, there's one for the digestive system cancer, urinary system cancer, hematological cancer, reproductive cancer, brain glioma, respiratory system cancers, melanoma cancers. You can go through all of this if you want, but the one I want to focus on is the digestive system cancer. This is the cancer that Kiara has. So gastric cancer is one of the most common malignant tumors worldwide. Numbara study showed that ivermectin could significantly inhibit the proliferation of gastric cancer cells in vivo and vitro, and the inhibitory effect of ivermectin depended on the expression of yes-associated proteins. The gastric center cell lines have higher expression than other cells, and again, to put it perfectly clear, make sure everybody understands, I'm not a scientist, I'm not a doctor, I'm not a veterinarian. I'm just a normal dude who's desperate for answers and options. And these abbreviations right here are explained right, I think here, abbreviations. But again, to me, it's just gibberish. It's not clicking in my head, so I don't know what these are exactly. But Basically, what it's saying is the gastric cancer cell lines have higher expression than other cells. So certain cells are sensitive to ivermectin while other cells are not sensitive to ivermectin. But certain cells play a oncogenic role in tumorigenesis, indicating the possibility of use of ivermectin as a YAP1 inhibitor for cancer treatment. So let's look up what YAP1 is. Further, here we go. So there's PAC1, PRR, ROS, YAP1. So triple negative breast cancer, YAP1 is a yes associated protein 1. That's what that means. YAP is yes associated protein. All right. So in the study that screened WNT pathway inhibitors, ivermectin inhibited the proliferation of multiple cancers, including the collateral cancer cell lines. It promoted apoptosis by blocking the WNT pathway. After intervention with ivermectin, the expression of the caspase-3 and LS174 cell T in DLD1 and LS174 T cells increased, indicating that ivermectin has an apoptosis-inducing effect and inhibits the expression of the downstream genes. However, the exact molecular target of the ivermectin that affects the WNT BK18 pathway remains to be explored. I assume that's just saying, hey, it works to do certain things. However, we can't really direct it to go into a certain way. So if it affects the cancer, it's probably just because you have a massive dose in your body that's pretty much affecting your entire body, which means the cancer then becomes collateral damage. But for the most part, ivermectin is, from what some doctors say, less harmful than a sugar pill. So you could take a lot and you wouldn't even notice. It wouldn't even faze you. So having that much in your system might actually be worth it if you're trying to attack cancer. Anyways, hepatocellular carcinoma is the fourth leading cause of cancer death worldwide, and hepatocellular carcinoma is what Chiara has. It's a kind of liver cancer. Approximately 80% of cases of liver cancer are caused by hepatitis B virus and hepatitis C virus infection. However, ivermectin could inhibit the development of hepatocellular carcinoma by blocking the yes-associated protein 1 activity in spontaneous liver cancers. They did this in mice already. So if they could do it in mice, I don't see why cats would be any different. But this cholangiocarcinoma is a malignant tumor that originates in the bile duct inside and outside of the liver, which is another thing they found in Chiara. But fortunately, they didn't find any cancer in that mass that they found in her bile duct or outside the liver, but they did say that it was connected, as if the original tumors from her liver had spread to that area. So it's safe to assume that it's just the same cancer that she has, the hepatocellular. Intuyod's experiment found that ivermectin inhibited the proliferation of KKU214 cholangiocarcinoma cells in a dose and time-dependent manner. Ivermectin halted the cell cycle in S phase and promoted apoptosis. Surprisingly, gemcitabine resistant KKU214 cells showed high sensitivity to ivermectin, which suggested that ivermectin shows potential for the treatment of tumors that are resistant to conventional chemotherapy drugs. So this means that even if you have a cancer like hepatocellular carcinoma that is extremely resistant to conventional chemotherapy drugs, because that's why I really don't want to go that route. It's a losing battle. They told me that Chiara has maybe a 20% chance of reacting well to it, and it's expensive. So it's expensive, and you only have a 20% chance of it working. It's just not worth the risk when you have ivermectin that is showing absolutely incredible results. Even if it's a long shot, it's worth to try something new than it is to try something that you know is probably going to fail. So that's why I'm doing this. But this also means that if we did give Kiara ivermectin, it could actually help make these cancer cells sensitive to chemotherapy drugs. So if we did that, it would be a double whammy, so to speak. But the only problem is we'd be putting Kiara through a lot more stress and pain when she might not need it if ivermectin is enough to actually treat her. So we now know that ivermectin on a molecular level has quite an incredible reaction, or let's just say an effect, a remarkable effect on cancer cells. So if that's the case, then we just need to know how much we need to take, right? Well, this is where it gets a little dicey, because this has only been done in humans. And in humans, a low dose is 0.5 milligrams per kilogram, as seen here on Ivermectin Articles and Protocols for Cancer, Research Studies, and Access to Ivermectin Pills. The low dose is going to be 2.5 milligrams or less per kilogram. And what that means is if you weigh 90 kilograms, right, and you're taking ivermectin to basically put cancers that are in remission out of your body completely, or just use it as a prophylactic to stop yourself from getting cancer, you would be taking about 45 milligrams of ivermectin, because you're taking 0.5 milligrams per kilogram. So 45 milligrams total would be what you would take if you weighed 90 kilograms. That's still a lot, because if you've ever seen an ivermectin pill, it's tiny. Like, it fits on the tip of my finger, and there's still so much finger around the pill. It's really small. And that's 12 milligrams. So you would take 4 of those in order to hit the right amount to treat your cancer if you're taking a low dose. 4 is a lot, because the normal amount is usually just 12 milligrams per day. But if you're quadrupling that, it's a lot more. That's 4 times more than what you'd usually take. So these are very large amounts, even at the low dose. A medium dose in this case would be 1 milligram per kilogram. And and with the 0.5 milligrams per kilogram, the low dose, Dr. Tess Laurie reported a case of stage 3 ovarian cancer treated with chemo and 12 milligrams of ivermectin per day. And her cancer cells dropped from 288 to 22 in just 2 months. And her tumors vanished. So that is remarkable. And again, this is just anecdotal evidence, but if it's better, like if these results are plausible for a cat as well, then it's worth trying, rather than going with the really expensive chemotherapy treatments that we know have a very, very low chance of actually working. So with the 1 milligram dose per kilogram, this is a medium dose. So if you weighed 90 kilograms, you'd be taking about 8 or 9 12 milligram pills. That's like a handful of M&Ms and M&M minis, if you've ever seen the mini M&Ms. So it's like popping 9 of those. Again, there's no long-term side effects. And Dr. Shankar Chetty reported a 70-year-old prostate cancer patient with a PSA 89, so 89% cancer cells, placed on 45 milligrams of ivermectin per day. After 2 months, the PSA dropped from 89 to 10. Ivermectin was given in combination with lactoferrin. So the crazy thing is there's chemo in this one, there's lactoferrin in this one, there's no additional drugs in this one, and there's no additional drugs in this one. However, they all have ivermectin in common, which is a huge indicator that ivermectin is probably the heavy lifter here, doing most of the work. Then in a high dose, 2 milligrams per kilogram. So if you weighed 90 kilograms, you would be taking 15 of these, like 14 or 15 of these 12 milligram tablets, maybe 12. No, yeah, 14 or 15 of these 12 milligram tablets is for very aggressive cancers, leukemia, pancreas cancer, brain cancers, but still we're not seeing any long-term side effects. And Dr. Alan Landrito had a stage 4 gallbladder patient who took 12 milligrams per day, or 2 milligrams per kilogram per day, for 14 months, and their cancer disappeared. So again, anecdotal evidence, but that's remarkable. And then very high dose, which is 2.5 milligrams or higher. So you're taking damn near 20 of these 12 milligram tablets. It's like you just emptied an entire thing of M&M minis into your mouth. This is for extensive metastatic diseases or extremely poor prognosis, maybe brain cancers. There's still a very small chance, but this is where side effects start to take place. So you might get short-term transient visual effects, hallucinations, delirium. But Dr. Shankara Chetty had another patient on 2.5 milligrams per kilogram per day with no side effects. So it's possible that you can get these side effects, but it doesn't mean you will. So now it begs the question, how much do we give a cat? I don't know. I really don't know. And that's why I've done as much research as I can into it, and I've developed a regimen that I will go over in the next video of what I plan on doing to treat her cancer. And as of right now, this is all just a guessing game for me. I am going in completely blind. I don't know what's going to happen. I just have the research that I've done and the amazing vet techs and veterinarian doctors who have actually given me so much information on what I could do to help her. They don't want to jump on board because their licenses might be on the line, and I totally respect that. So I'm not disrespecting them in any way, shape, or form. They did an amazing job. They took really good care of her. They did so much for me. So shout out to all the veterinarians and the doctors out there that were helping her out. But I'm going in solo with this because they don't know how much to give her, and they don't want to risk their license by giving too much and possibly killing her. So we're going to play this real safe, real slow, and I'm going to go over the regimen and the other information that I have researched, and I'll make a video describing that case by case. But just keep in mind that with that next video, it's a lot of trial and error. It's a guessing game. So a lot of the information has been changing as I've been going over it. So that's for next time. Hope you guys found this informative.